Question number 1 was chlorine can be prepared in the laboratory using potassium permanganate. Remember, it is potassium permanganate or manganese 4 oxide that can be used. I keep reminding you that all the two, potassium permanganate and manganese 4 oxide, are oxidizing agents. So in their reaction, they react with concentrated hydrochloric acid. Concentrated hydrochloric acid and they oxidize hydrochloric acid. Oxidation in that case is removing hydrogen. They oxidize hydrochloric acid to chlorine. So, and the conditions when you use manganese 4 oxide, you must heat, and when you use potassium permanganate, there is no heating that is required because the reaction can take place at room temperature. So question 1 was name one substance that reacts with potassium manganate 7 to produce chlorine. The answer, many of you gave it to me. Thank you so much. The answer was concentrated hydrochloric acid. Note, I crossed those who said conc hydrochloric acid. I've always told you to avoid those abbreviations. They don't work for us. Then we also crossed those who said hydrochloric acid. You must tell me whether it is concentrated or dilute. But in that case, we wanted concentrated hydrochloric acid. State the condition for the reaction. The condition is no heat is required. Condition is no heating, or someone can say room temperature just. So the condition is no heating. Write an equation leading to formation of chlorine. Remember that equation for formation of chlorine from potassium permanganate? I think you remember very well. So just check in our notes and get it. And when you are balancing, remember there is 16 on hydrochloric acid. I'm sure you are not lost there. A boiling cube filled with chlorine, that was part B, and the diagram is still here on our screen. A boiling cube filled with chlorine. This is the boiling cube they are talking about. Filled with chlorine water. The chlorine water is here. And exposed to sunlight. The sunlight is here. The question is, state what was observed. Many of you are saying a yellow solution. No, we know that chlorine water is a yellow solution, but I have always told you. Now listen, my friends. When there is a gas given out and there is any solution, whether water or any solution, there is a gas given out and we ask for the observation, don't think twice. The observation should only be about that gas that has been given out. And how do you talk about observation of a gas given out in solution? You simply say bubbles of a colorless gas. So I only wanted that, bubbles. And those who wrote bubbles, I gave them the whole mark. Those who wrote bubbles, I gave them the full mark. You get that? So when there is a gas that is given out in solution, when there is a gas that has been given out and there is water or any solution somewhere, and we ask for the observation is bubbles of a colorless gas or effervescence. The word effervescence is just a substitute of bubbles. The two mean the same thing. Whenever bubbles are given out, then there is also effervescence. Take a look at for after the lesson, you just buy a bottle of soda and open it. You will see the bubbles being given out, but at the same time, there will be effervescence as soon as you open the bottle. So the observation was effervescence. Explain with aid of equation or equations. Now, many of you don't know how to answer that question. When we say equation or and we put S in bracket, we are saying it is either one equation or they can be two. Do you get that point? When we say explain with aid of equations and we put S in bracket, equation and S in bracket, it means either equation or equations. So the equations for this reaction, the equations that lead to the formation of oxygen gas in this equation, I told you there are two. But if we ask for one, then you give the last one where oxygen is given out. So someone can say chlorine reacts with water to form hypochlorous acid and hydrochloric acid, and you write the equation. I hope you are answering. We are explaining our equation, which is bubbles of a colorless gas. So the first equation, you can say chlorine reacts with water to form hypochlorous acid and hydrogen and hydrochloric acid, and we write our first equation because the question needed you to write either one equation or two. So for someone who wants to write one equation that leads to formation of chlorine, of oxygen, is that one, the first one. So if you write this one only, we give you 2 marks. But if you want to write two, then this is the first one, where chlorine first reacts with water to form hypochlorous acid and hydrochloric acid. So that is the first one. And they are saying explain, so you should write some words. So let us write and say chlorine reacts with water to form hypochlorous acid and hydrochloric acid. That is the first thing that happens. Chlorine reacts with water to form hydrochloric acid and hypochlorous acid. So that is the first equation, and we write it. Then below that we can say sunlight decomposes hypochlorous acid. So the role of sunlight is to decompose the hypochlorous acid. It means without sunlight, then you will never get oxygen. That's why the whole apparatus is taken where there is sunlight. So sunlight decomposes hypochlorous acid, forming hydrochloric acid and oxygen. Then we write our second equation. So when you have hypochlorous acid already, then the equation that leads to formation of oxygen is this one. But there is, when we ask for one equation leading to formation of oxygen, I told you the other time, just write this one. The last equation that leads to formation of what? Oxygen. So when we ask for one equation, either write this first one, the first one here, or the third one, where there is oxygen. But don't write all the three. You are wasting time and giving us hard time also to choose. And we don't choose for you. So, and in situations where we want only one equation and you write two, if one is wrong, then it cancels out with the correct one, and the overall is 0. Part C was an interesting question which we have always seen. Write an equation to show how chlorine can react with part 1, potassium hydroxide. Many of you passed that. Potassium hydroxide and dilute potassium hydroxide and chlorine. The equation is this one. It forms potassium hypochlorite plus potassium chloride, then plus water. Thank you for passing that one. I was happy. Then hydrogen sulfide with chlorine. The equation is here. Many of you passed it. And in that case, chlorine is working as an oxidizing agent. Remember, I told you that oxidation is also removal of hydrogen. So chlorine removes hydrogen from hydrogen sulfide and it forms hydrogen chloride and sulfur. So I told you if I were to ask for the observation in this reaction, what would be the answer when chlorine reacts with hydrogen chloride? Jasmine.
Yes, teacher.
What is the observation when chlorine reacts with hydrogen sulfide? According to that equation, what would you write as the observation? Save time. Wama, Ruth, tell us. Is Ruth here? Yes, Esther Ruth. See, some people are not following. Esther Ruth, are you there or you also don't know how to unmute? Someone tell us and save our time. What will do right as the observation when chlorine reacts with hydrogen sulfide? The products are hydrogen chloride plus sulfur. What shall we write as the observation? The answer is just, yes, Edward.
Bubbles of a colorless gas.
No way. Chlorine and hydrogen sulfide, where are the bubbles coming from? All of these are gases and the states are gases and solids. Elizabeth.
A yellow solid of sulfur and white fumes of hydrogen chloride are formed.
Great. Thank you. Wonderful. That's very correct. You people, the answer is just right here. You are even not reading it. Yellow solid, the yellow solid is here. It is sulfur. Sulfur is a yellow solid. And I told you where hydrogen chloride appears, it is always white. It always appears as white fumes of gas. So if I had asked for the observation, which is very possible, then you would have told me that a yellow solid is formed and white fumes of a gas. Then chlorine and turpentine. The reaction between chlorine and turpentine, we also looked at it, and the answer is just right here. Chlorine and turpentine wire. I think you remember I was telling you that carbon is formed in that case. So turpentine is here. It is first melted as a liquid. it is first melted as a liquid. So that is turpentine, C10H16. Then when we add chlorine, we get carbon, and carbon, there are 10 at 10 molecules plus 16 for hydrogen. So the equation is that one, and it does not change. It stays as it is. Don't change anything. Just know turpentine is C10H16. When it is heated with chlorine, the products are carbon and hydrogen chloride. Then to balance, begin with hydrogen. You put 16 on hydrochloric acid, then you put 10 on carbon. So that's the way it is, and that's the way it should be. Then chlorine gas was bubbled in a solution of iron 2 chloride. Remember, we looked at that on oxidation. When chlorine is bubbled through a solution of iron 2 chloride, the answer is right here. When chlorine is bubbled through a solution of iron 2 chloride, a pale green solution of iron 2 chloride changes to yellow. So that was the answer. A pale green solution turns to yellow. That is the answer I wanted. Write the equation. The equation is here. Iron 2 chloride plus chlorine giving us iron 3 chloride. But we also accept ionic equation, whereby we have iron 2 ions from iron 2 chloride plus chlorine gas forming iron 3 ions plus chloride ions. So the ionic equation is also accepted. So the equation is there. Then after the equation, we are saying state the property of chlorine being used. The answer is here. Chlorine is an oxidizing agent. So I'm repeating these things because they are very important. They are very important. You people, please take time, go through the work. The questions I give you are also equally important because they summarize what we have been looking at. So let us move on now, and I'm introducing something new: displacement reactions. Displacement reaction of chlorine. Now, if you remember, we said that as you move down the group, then reactivity decreases. Reactivity decreases as you move down the group. What is the first element in the group for group 7? The first element is that one whose atomic number is 9. So the electronic configuration is 2 to 7, and that element is fluorine. That means fluorine is the most reactive element in group 7. The second element is chlorine, meaning chlorine is the second most reactive element in group 7. The third is bromine, meaning bromine is the third reactive element in group 7, followed by iodine. So the most reactive element is fluorine, but we shall look at reactions of fluorine in senior 6. Remember what you promised me, that you are all going to do chemistry in A level. So let us meet there, and we shall look at reactions of fluorine in senior 5 and senior 6. But in our senior 3, we shall concentrate on chemistry of chlorine. Now, displacement, you remember the reactivity series. If chlorine is more reactive than the other elements which are below it, elements of bromine and iodine. If chlorine is more reactive than bromine and iodine, according to the knowledge of reactivity series you know, then chlorine is going to displace bromide ions and iodide ions in their solution. So that's what we mean by displacement reaction, where a more reactive element displaces another element which is less reactive in its solution. Okay? So I want to first show you what happens in displacement. For example, this is our chlorine gas, but we are saying it is more reactive than bromine. So first do like this. On your book there, your notebook, write order of reactivity. Then the first one is fluorine. Its symbol is F. Order of reactivity, the first one is fluorine. The symbol is F. It is followed by chlorine. The symbol is Cl. Followed by bromine. The symbol is Br. Followed by iodine. The symbol is I. So meaning chlorine gas displaces bromine and iodine. But bromine gas can also displace iodine. So let us study this equation together. Chlorine plus potassium bromide. So this is a solution of potassium bromide. But since chlorine is more reactive than bromine, then it is going to displace this bromide from its reaction. It is going to displace the bromide ions here from their solution of potassium chloride. So chlorine displaces bromine from its solution. Chlorine displaces bromide ions from the solution of potassium bromide. And when the bromide ions have been displaced, they will form bromine gas. So it is now bromine gas that is formed, and chlorine takes the place of bromine. We usually ask you to state what is observed and explain your observation. I want you to run this with people. So what are we saying? When chlorine is bubbled through a saturated solution of potassium bromide, so this is the solution of potassium bromide. Now potassium bromide is colorless. The colorless solution immediately turns to red. What is red is bromine liquid. What is red is bromine liquid. Due to formation of bromine water. And a drop of red liquid bromine is observed at the bottom of the boiling cube. So bromine water is reddish brown. Let us also note that down also. Bromine water is reddish brown. Then bromine liquid is red. Bromine liquid, I mean bromine which does not contain water. So the observation is the colorless solution turns to red. The colorless solution turns to red, and a drop of red bromine is observed at the bottom of the boiling cube. A drop of red bromine is observed at the bottom of a boiling cube. So let me summarize it for you. When I ask for the observation, just say colorless solution turns to a reddish brown solution. Colorless solution turns to a reddish brown solution. Why a reddish brown solution? Because potassium chloride that is formed is in aqueous state, which means it is in water. So when liquid bromine is formed and there is some water, it also becomes bromine water. It also becomes bromine water. Or you can say a colorless solution turns to red, and you write this equation. We allow all of them. Just say a colorless solution turns to red and stop there. Then write the equation. But we shall ask you to explain your observation. Now this is where I need you. You'll say, I need you to be attentive. You'll say, chlorine is more reactive than bromine. You get that? Eh? Chlorine is more reactive than bromine. Therefore, chlorine displaces bromide ions from the solution of potassium bromide. Chlorine is more reactive than bromine. Therefore, chlorine displaces bromide ions from the solution of potassium bromide forming bromine liquid, which is red. I repeat the explanation. If I ask you to explain your observation, the observation is a colorless solution, which is potassium bromide, turns to a red solution. Yeah? And the explanation, I'm saying chlorine is more reactive than bromine. Therefore, chlorine displaces bromide ions from the solution of potassium bromide, forming bromine liquid, which is red. Now, let us look at this one also. Potassium iodide plus chlorine. Again, the same story is what we are going to talk about. Remember, potassium iodide is colorless. So when it reacts with chlorine, chlorine will displace the iodine from potassium iodide, because chlorine is more reactive than iodine, and it will form potassium chloride plus iodine. So when we ask you for what is observed, the colorless solution turns to dark brown. And what is dark brown? That is iodine. Eh? Okay. And after some time, the black solid of iodine is deposited as iodine, which is slightly soluble in water. You know, iodine is slightly soluble in water. So after some time, you will see a black solid settling at the bottom. So the observation here is the colorless solution turns to dark brown. What is dark brown is iodine. Explanation. Chlorine, the same thing, nothing changes. Chlorine is more reactive than iodine. Therefore, chlorine displaces iodide ions from the solution of potassium iodide, forming iodine liquid, which is dark brown. Reaction of chlorine with nonmetals, and here we can look at phosphorus. When phosphorus burns in chlorine, it forms phosphorus trichloride. This question was asked in UNEB last year, I think. When a piece of dry phosphorus is lowered in a gas jar of chlorine, it burns spontaneously, giving off white fumes of chlorides. Mainly, the chlorides are phosphorus trichloride and phosphorus pentachloride. So two reactions take place. The first reaction is phosphorus plus chlorine forming phosphorus trichloride. And that is the first one. Then phosphorus plus chlorine forming phosphorus pentachloride. In some books, you are going to find when they write one atom of phosphorus P in solid plus chlorine forming phosphorus trichloride, it is still the same thing. When they write P or they write P4, they are the same things. So take note, when chlorine reacts with sulfur, these are the two reactions that occur. You form phosphorus trichloride and phosphorus pentachloride. This is the same case that occurs when phosphorus burns in oxygen. Remember, it forms phosphorus trioxide and phosphorus pentaoxide. So visit that work and remember it very well. Then sulfur reacts with chlorine to form disulfur dichloride. But this is not common. This is not common. These ones, we looked at them. Sodium plus chlorine with metals. Sodium plus chlorine, we form sodium chloride. Then magnesium plus chlorine, we form magnesium chloride. These ones, we looked at them. But I want to take you to the most important reaction of chlorine, you people. Action of chlorine on iron. This is very, very, very important and very common. When chlorine is passed over heated iron wire, when chlorine gas is passed over heated iron wire, the diagram is also there. So iron 3 chloride is a black solid. Iron 3 chloride is a black solid. And if we at all we ask for the conditions, then chlorine must be dry. That's why you are seeing it is passed over calcium chloride to dry the gas in a U cube. The conditions are chlorine gas must be dry. Then the iron must be heated. It must be red hot. It must be heated and it must be red hot. So this reaction is exothermic. So when chlorine is passed over heated iron wire, it forms iron 3 chloride. It does not form iron 2. Take note. The product is iron 3 what? Chloride. We usually ask for the observation. The observation is the chlorine, the iron grows red hot and continues to burn. The reaction is exothermic. So the observation, when chlorine is passed over heated iron wire, black crystals of iron 3 chloride are formed. But remember, iron 3 chloride can sublime, because since you are heating. So later on, it will do what? Sublime. The equation is here. Very, very, very important and very common. Iron plus chlorine, the product is iron 3 chloride. And it is balanced. The equation is balanced. Please, I repeat, the product is iron 3 chloride and not iron 2 chloride. And the observation is black crystals are formed. The black crystals are of iron 3 chloride. Now, we usually ask about iron and hydrogen chloride. If at all you are using hydrogen chloride gas over iron, then the product is iron 2 chloride. And for iron 2 chloride, it appears as a white what? Solid. If I assure you, I confirm that these two reactions are very, very important. Someone serious should have written these two equations. The first one and this third one. In the first one, iron 3 chloride, if we ask for the observation, they are black crystals. But since we are heating, the black crystals will sublime and collect in a small bottle, which acts as a condenser. When you heat iron ethyl chloride, it sublimes. It has properties of sublimation. Then if it is chlorine with hydrogen chloride gas, we are saying the product is iron 2, chloride and hydrogen. Uses of chlorine as we finish up. It is used as a bleaching agent. Just remember JIC. I told you the largest percentage of JIC is chlorine. And the role of JIC is to bleach, to remove dirty stains or marks on clothes. It is used in making domestic antiseptic solutions. So antiseptic solutions, we mean like in septic tank, to kill germs there. So that's the role of chlorine. Then another important one, it is used in manufacture of chlorates, such as it is used in the manufacture of hydrogen chloride gas. Chlorine is used in manufacture of hydrogen chloride gas. So the important one is number 1, number 4, then number 6. It is used to kill germs in water. Remember, water purification. So that is it for today. We shall stop here and add on next time. Send your questions in my inbox. I will answer them. Next time we are starting on hydrogen chloride. Have a good day. God bless you. Bye-bye.
Bye, teacher.
Bye.
Bye.